Alright, so ladies and gentlemen, as I previously mentioned, we are jumping into stats. Chapter 20 is called Descriptive Statistics. What do you guys think Descriptive Statistics is about? Exactly right. So we are going to learn about how we can display the data. So we're going to look at different graphs and charts that we can use, a few different types of those. We're also going to talk about the measures of central tendency, which you guys already know a bit about, like mean, median, and mode. We're going to start talking about that tomorrow. We are going to talk about something that's probably new called cumulative frequency graphs towards the end of the chapter. And then we'll also end up with variance and standard deviation. Do you guys know, have you heard of standard deviation before? Yeah, where have you guys heard of it? When smart people are talking? I was thinking you guys were going to say like psychology or something like that.
Sociology.
Or sociology. So by the end of this chapter, you should understand like what that means and how to calculate it. And some of the things that are interesting is that there are ways to do this stuff by hand, but then there are also ways to use technology like TI-84s to calculate this stuff as well. You need a calculator for sure. Even if you do it by hand, you need like a scientific. So we like throughout the chapter we'll talk about like how we can do it by hand, and then we'll also talk about how we can use technology at times as well. So 20A is about key statistical concepts, and then I added this on. Put that phone away. I'm not going to wait for you to write stuff down because you're not writing because you're looking at your phone. So there's a lot of writing and a lot of vocab. Because it's those key concepts, like things that we just have to cover. And some of it you'll be like, oh yeah, I know that. But some of it I think might be a little bit new as well. So, you know, as we go through the vocab, remember, write down what you need to write down. If you don't need to write that at all down, that's up to you as well. So we are going to get a stat box. And then jump right into that vocab. So first of all is the population. So the population is the whole collection of objects we are interested in studying. So for example, if we're studying the height of women, the population is all of the women in the world. If we're studying the GPA of students at Case High School, the population is all of the students at Case High School. So population tends to be really, really big. It's this very big group. And what we'll talk about a few slides from now is how it's not always possible to get information from every single person or object in the population. Now, if we could get information from the entire population, that would be called a census. So if we can collect information from the whole population. So a census would be like if we were able to reach every single student at Case High School and figure out their GPA. Not just picking random students, but every single one, that would be an example of a census. Now, you know, it's unreasonable probably that we can, you know, get to every single person or every single woman if we were looking at like the heights of women. Do you guys know what it's called if you're just looking at like a part of that group, or like how you get information from a part of that group? I feel like once you see the word, you're gonna be like, duh. That's a sample, right? So a subset of the population, which should be chosen at random to avoid bias in the results. So, you know, if we were, I like this example a lot, but so if we want to find the average weight of household cats in America, we are not going to be able to reach every single So what we would want to do is use a sample to spot. So maybe we, take a look at just certain homes or something like that, but you want to try and choose it randomly so that it's not biased, but, we try to do that. I know there's different types of samples and stuff like that in surveys, but we're just going with like the basic part of it for now. So I know I've already said this word, but how do we get information from a sample? Well, that's called a survey. Collection of information from a sample. Now, do you guys say data or data?
I think it just happens.
Okay. All right. So that information that we receive about a population is called data. So if we do a survey and we get some information, we've got some data to work with. Or some data to work with, whichever. I know, I end up, yep, I agree with that completely. That's how I'm either or.
My cousin's from Vegas said that we pronounce our A's like so much differently. Like the A's especially.
All right, so we are not done with vocab. It keeps going. No, we were talking randomly.
It was about them.
All right, so when we get the data, it might be categorical. So categorical data describes a particular quality or characteristic which can be divided into categories. For example, music preference. If we surveyed the senior class to find out if they like hip-hop or pop or rock or whichever, like that's a category. It's not a number answer. Maybe we're surveying for, I don't know, favorite color, favorite restaurant, or something like that. Like that's categorical. It's a category, not a number. So, there will be some surveys, some data that ends up being categorical. You might guess that we are going to do a lot of work with data that ends up being numerical, and that's going to be what we talk about next. So when we talk about the numerical variables or numerical data, that describes a characteristic which has a numerical value that can be counted or measured. So really important that we know the difference between the two types that we're going to dive into next. So here I'm going to define the type, but then also give you some different examples of what would fit into those two types of numerical data. So the first type is called discrete numerical data, or numerical variables. So discrete numerical variables, they take exact number values and are often the result of counting. So discrete would be something we can count, so there's only whole numbers. Discrete is like how many. And as you can see, we have big, bold, and blue. Discrete is like counted. You can count this. So for example, I would not write this first one down. Let me describe this first one. I just don't think it's worth writing down. But like, if we flip a coin, we could count the number of tails. Like maybe that's what we're trying to figure out, how many tails. The number of tails is any integer between 0 and positive infinity. We're not going to have 2.5 tails. So you guys get why it's like whole numbers we can count, like how many it happens? Or like the number of people in a classroom. If we're trying to figure out the average number of students that attend third hour, like in each class, we could come in and count all of you and count it out. So discrete is counting. So if you want to write an example, I would say like the number of people in a classroom would be a good example to write down. The other type is called continuous variable. These are still numerical answers, but they're numerical values within a certain continuous range. Also, I was thinking about this, I would almost even prefer the word like interval. Seems to come up a little bit more. So it's like within an interval. Now, the thing is you could have any value within that interval, including decimals. So these are not whole numbers. This is something that you would measure. So this isn't something you would count, it's something you would measure. What do you guys, can anyone think of like something you could measure? Height, absolutely. Because if we were measuring height, it's unlikely you're going to have people with the exact same height, right? But we could do it in intervals. Maybe we do it within 3 inches. So from 60 inches to 63 inches, from 63 to 66, 66 to 69, so on. So like you could be anything. You could be 60 inches or 60 and a half or 60 and 3/4 or whatever, like in between that. So this is something that you would measure. A lot of the data we will look like will fall into this continuous type. So if you are not sure, make sure you're asking some questions. But again, we do have some more examples on the next slide of like things that would be measured. So we already talked about the height of people, speed of a car, the weight of those house cats. You know, if we weigh those house cats in pounds, they're not all going to be like 15 pounds. You know, they might be 15 and a quarter, 15 and a third. Like, there'd be a range of weights that we would use. So that's the example of that continuous type of information or variable. So I would not necessarily write this whole table down, but I want to kind of talk about the different parts of it. So we've got a frequency table, and I'm going to zoom it in a little bit to talk about the most important parts. And I would say the first 3 columns are what's going to be most important here. So your first column is your value. That's like whatever you're measuring. So this one doesn't have a lot of information. We don't have a title, so I'm not exactly sure what's going on. But let's say we were measuring how many dollar bills you have in your pocket. So like maybe you have 1, 2, 3, 4, or 5. Well, then you would tally it up. So let's say I would have everyone, you know, take out their dollars and then be like, okay, all right, so I only have $1, but let's say that we've got someone else has 2, someone else has 5, okay, another person has 5. So you just mark a tally for like every one that happens like in that, you know, in that value we're looking at. And this could be continuous as well. This could be a range. We're going to look at an example that has like an interval here. So once you do all the tallies, then you have the frequency. So 8 people had $1 bill, 2 people had $5 bills, or something like that. So these first 3 columns are, I would say, what's most important. You're going to be using those for sure. I'm going to talk about this next, but are there any questions on those first 3? Have you guys made frequency tables before? Probably just didn't know I had a name. Like when you're tallying something up, doing some kind of survey. So relative frequency is this last column, which you're not going to see all the time, but it's still important to understand. The relative frequency measures the percentage of the total number of data values that are in each group. So for example, you know, there were 30 people that we took a look at. There were 30 total people. 8 of them had $1, so that's 8 out of 30. So that was 26.7% of the people we surveyed had $1. And if we take a look at, let's say $3 here, 20% of people had $3 in their pocket. So if you do see that relative frequency, do you guys know how to calculate percents? I mean, that's something you do in Algebra 1, but it's been a while. So if you don't know how to calculate percents, maybe jot that piece down. So it's like the part is 8 over the whole is 30 times by 100 to make it a percent. So just in case you've forgotten that along the way, part over whole times 100 will give you that percent. So this frequency table is all fine and dandy, and there's a lot of information that we can get off this frequency table, but sometimes it's nice to actually display our data in a way that's a bit more visual. So we're going to talk about two different types of displays today. We'll also talk about like box and whisker plots later on. We'll talk about that cumulative frequency graph, which is kind of crazy, a little bit later in this chapter as well. But today we're going to kind of go over some of the basics. So there's two types. The first one is a column graph, also known as a bar graph. You guys remember bar graphs from back in the day? So, and I have to confess that this column graph and the one we're going to talk about next, I didn't even know they were two different things until like 2 or 3 years ago. Miss Huff kind of set me straight, like get it together. They are not the same thing. So the deal with the column graphs is that they're used to either display discrete numerical variables or categorical. So not that continuous information, just those certain numbers, like how many dollars you have. You have $1 or $2. You don't have $1.50. So it has to be discrete. Or those categories, like those music genres we could have down here, like the different information. The thing here, the kind of important thing is that there are gaps in between because there's no range, it's separate. So if we have pop music and hip hop and rap or whatever, like it's all separate. Or $1, $2, $3, $4, like there's no connection, so they actually have gaps in between the columns. So the other type of display looks very, very similar. Like I said, I used to think they were the same thing, but it's a little bit different and it uses the continuous data. And they're called frequency histograms. So we use this to display the continuous variable data, and because it's grouping into class intervals with equal width, you want those intervals to be equal. You don't want to have those big differences. You want those intervals to be equal. So for example, those heights, maybe we group from 60 to 62 and 62 to 64 and so on. So kind of figuring out those groups. Now here's the big difference is there are no gaps because it's like a continuous, you would have 60, 62, 64, 66 and so on here because they're not completely separate. They're continuous. They're sort of touching. So we can use these data displays to find different information. We'll talk more about that as we move on into future chapters as well. But we can also kind of see distribution. So we're going to talk about distribution next. So distribution is the shape or pattern of the data. So that's the way that something is skewed will tell us which way the data stretches out. So there are kind of 3 different types of distribution, so we'll sort of look at a picture for each of those. And this is definitely something that the more you use, the more you'll get used to it. When you're asked about the distribution, make sure you try answering it and then make sure you're checking your answers in the back so I can make sure you're understanding the different types of distribution because it's a little bit different. So the first type is called symmetrical. So you can see with the symmetrical, it is symmetrical. We start low, we have the most sort of in the middle, and then we go back down to a low amount. So looks like a nice even hill, if you will. A curve. So then the next type, did you guys all draw a little picture of symmetrical? Highly recommend that. These pictures are straight out of your textbook if you need to go back. Positively skewed. Now first, this is like hard for me to remember, but positively skewed, it kind of starts out with the most and then sort of tapers down and gets lower as you go on. I get a little bit confused because I think like, oh, that's the negative side of the number line, but we're not like, you know, going into those integers, those negative numbers. So if it starts off kind of high, then it's positively skewed. What do you think the last one is? A negatively skewed is when it starts off low values, but then it ends up towards the end has our higher numbers. That's negatively skewed. You're almost done with notes. How do you guys feel? Almost there? We're not done with writing though. Oh, but this is stat box. Okay, real quick with that stat box, what's the difference between those column graphs and histograms? I heard someone say it. The space in between. Column graphs have a space in between. Histograms don't. What were you going to say, Stu? Oh, aren't touching, yep. How do you know which one to use? Yeah, if it has a range, if your data is in intervals, you've got to use the histogram because it's touching, that continuous. But if it's all separate values, then you can use your column graph. All right. The last few vocab words here are modal class. The class of values that appears most often. Have you guys ever heard that before? Like something that appears the most often? What have you guys heard? The mode, right? So the thing is when we have that continuous data, it's not just one number, it's that range of values, that interval. So the modal class is like the range that happens the most or appears most often. A parameter is a numerical quantity measuring some aspect of the population. For example, mean. You guys have heard of that before, right? The mean, median, the mode, those measure stuff. Also, standard deviation. I know I mentioned it earlier, and we'll learn a lot more about standard deviation towards the end of this chapter. So, a parameter is just something that it's a number that measures something about the data. And last but not least are outliers, data values that are either much larger or much smaller than the general body of the data. Have you guys heard of outliers before? Maybe? I always thought outliers, you just kind of like eyeballed it and you're like, huh, that number looks real big. It's probably an outlier, or that number looks very small. But in the middle of this chapter, we'll learn there's actually a mathematical way to calculate if a number is an outlier or not. Like, if it's not just, hey, it's really big, it's like there's actually a way to calculate that. So this section in particular has so much stuff Because it's all those key statistical concepts that we'll end up working with and talking about that we just have to sort of start with here. And so, we're about to get to the assignment. Okay, so here's the deal. I just want to explain something really quickly as we start looking at this. So, as I mentioned earlier, we talked about changing the plan. So this is the first time that Ms. Kranz and I are teaching this material. So we're kind of going based off of Ms. Elon's assignments. So they might be switched up a little bit from what she usually does, but for the most part, we're like, okay, she's taught this for a few years. She knows what questions are the best ones, right? So her suggestion was to do 1 through 4 for your assignment, but that we do 1 and 2 together as like an example. So unless you guys are opposed, I'd say let's start your homework. Yeah. Out of 4 problems, we can get 2 done, and then you only have to do 2. All right. We'll come back to this opening problem a little bit later this week, so ignore that for now. So we're going to first talk about number 1. So this is some of the data from number 1, but I didn't want to put the full question, so if you need to grab a book, go ahead and grab a book. And with statistics, not all the questions, but you definitely get some questions where you have to explain or think about it. So it's not all just crunching the numbers. Yeah, parts of it are, but some of it is sort of analyzing that data. Yep, they're not bad and dry. So we're on 20A. This is number 1. So I'm going to read number 1. It says, a frequency table for the heights of a basketball squad is given. So that's the basketball squad height. I enjoyed that as well. So 1A, I'm not going to write it up there because it's explained. So let's talk about it. 1A says, explain why height is a continuous variable. There might be multiple ways to explain it, but what do you guys think? Why is height a continuous variable? Yep, you can have decimals. Definitely one good way to explain it. Yes, there's a range, and we can see that from the table. They have a range of the height in centimeters. Let's see. If you said you measure height, you don't count it, that would make sense. I'm not going to count how many centimeters tall you are, right? Like, we measure it. So all of those would be good answers for part A. Part B says, construct a frequency histogram for the data. The axes should be clearly marked and labeled, and the graph should have a title. So we're going to make a histogram. What should we title our graph? Or our histogram? Absolutely. Heights of basketball squad. So when you are constructing your histograms or your column graphs, the data you're measuring, the different categories, or in this case, the different intervals will go on the x-axis, and the frequencies will go up. So if we've got the axis right here, here would be my heights along the x-axis, and the frequency would be my y-axis. Did you guys notice anything about these intervals at all? 70 to 175, 175 to 80, 180 to 185. Do you notice anything? They're all the same. They're all going up by like 5 centimeters, right? So that is something, if you are making your own in the future, you want to make sure that these are even, that they're like the same. Also notice that like if you are exactly 175, you're actually going to be in this section, right? We look at it very closely at our less than and equal to measures, so just some little things to keep in mind. Now you've got two options when you put your heights down. You can either start right here with 170, sort of like where the 0 would be, or if you want to, do you guys remember this when you're little, that little like skip thing?
Yeah.
I don't care which one you do. You can either put the little skip in, or you can start with 170. So I put the skip in, so I guess I'll just go with it. So I think we're going all the way up to 205. I'm going to try to make them even. I'm terrible at getting things even on the smartboard, as you guys all know by now. But in mine, it always goes downhill. I feel like it's worse than the chocolate. Okay. So, then for the frequency, we have to at least get up to 11. You can choose to go, but count by whatever you want. I decided to count by 2s. That just was faster for me. But if you want to count by 1s, like I'm not stopping you. And then you end up putting in your columns. And so, my first column only goes up to 1. The second one's all the way up to 8. I know I'm standing in front of it, but I'll move in a moment here. Next I'm up to 9. So you guys see how we're just using that information? We're going up to the frequency based on what's in the frequency column. So from 180 to 185 centimeters, there were 9. I feel like that might be a little high. I think I'm a little crooked here, but not 10, only up to 9. So the next one's up to 11. So do you guys feel like you can make a histogram? So then next question, part C, says what is the modal class? Explain what that means. Remember, modal is like mode. It's the most. So that's what it means, the values that appear the most. So what heights show up the most?
185.
Very good, 185 to 190. We can clearly see that from our histogram. That's the tallest one. So 185 to 190 is the modal class. The most people on the squad fell into that height. I mean, yes, we can get that from the frequency table, but isn't it kind of nice to like visually see that it's the most? And then we've got part D, which is personally, I think, one of the more challenging parts, but maybe not for you guys. Describe the distribution. So as you say, it's symmetric. Is it positive? Is it negative? What do you think? See, that's what I'm saying. I feel like these are the trickiest. Now, looking at it, I feel like it's slightly positive. Not completely, it's slightly positive. So when you get to those types of questions, and they're going to show up more than just this section, try to answer it and then check the back of the book. You're going to learn, like if you're wrong, like if you say it's symmetrical and they describe it as slightly positive, you can be like, okay, now I know what to look for. I know that that's, it's called slightly positive. All right, that's it for number 1. Do you guys want to do number 2 together? We still have time. We have 5 minutes. I mean, if you want to do it on your own, I'll let you. But if you want, we can do it together. So number 2 says, A school conducted a survey of 60 students to investigate the time it takes them to travel to school. The following data gives the travel times to the nearest minute. So all these times were rounded to the nearest minute. So part A is another discussion type question. Is travel time a discrete or continuous variable? This is it's a little bit tricky. So we got both answers, continuous and discrete. What? No, what were you saying? Well, okay, because you're right, it's continuous. Because these were rounded to make them appear discrete. That's why this one's tricky. It looks discrete. I don't see any decimals on this list, but they were all rounded, so it was continuous. We're measuring time in that range. People could have taken, 3 minutes and 30 seconds, but we didn't write 3 minutes and 30 seconds. We rounded it to 3. So because it was rounded and it's that time is measured, it is continuous. Part B says copy and complete the frequency table. Oh, this is number 2B. So the frequency table looks something like this. So you've got your tally section, your frequency, and then the time is that first part. And you'll notice that they divided the time into even intervals for you. So 0 to 9, 10 to 19, 20 to 29, 30 to 39, and 40 to 49. Yep. So if I wasn't doing this with you, what would you guys do next? So we copied the table, but how would you complete it? Yeah, the tallies. You would just take your time, be careful. It's really easy to make small mistakes here, and just tally it up. So, okay, 12, 15, 16. I just did the first row, but you get the idea, right? So I'm going to give you some time. If we can't finish C and D before the bell rings, you can always ask them tomorrow if you can't figure them out on your own. But you keep going. Like I said, I just did the top row. This is also definitely something that I would check your answers in the back, because you could just, accidentally skip a column or something, right? Like you might just miss one because there's 60 numbers you're looking at, plus I'm talking to you as you're trying to do this, so that doesn't help. To speed things up for the purpose of class, you should end up with these frequencies. So 6, 26, 13, 9, and 6. Now, and if you don't, again, you probably just made a tiny mistake, so don't get discouraged, but do check in the back to make sure that you know what's going on. Now, we are not asked to make a histogram here, but we are asked about the distribution. Describe the distribution. So do you think it's symmetrical, positively skewed, or negatively skewed? And these get kind of tricky. Yeah, because my bigger numbers are towards the beginning, so it's positively skewed. Now, personally, it's also harder for me to do this without the actual picture to show me, but, as we practice this, we'll all get better at it. And then for 2D, what's the traveling time modal class? most students take somewhere between 10 and 19 minutes to get to school. That's clearly the interval that has the highest frequency. So those are some of the basics. We're going to get into mean, median, and mode starting tomorrow.